Hello students, welcome to the week 8 example 1 video. So for this week we're doing it a bit differently. So once again there's no sketch on the slides. You're going to have to watch the video, but also additionally I'm not going to be exactly creating the model from scratch as I did in the previous videos, as this would create a much longer video than is necessary. So I created the model and then suppressed all the features. And now I'm going to go through all the things that I did with you. Okay, so this will also be the last week of modeling that we will be doing in the Excel course for this year. From next week, we're going to be doing assemblies for 2 weeks, and then you have a few weeks with only informative content and no homework or so on, so you have time to work on your projects. Okay, so let's get started. Okay, so for the first sketch, I created on the top view this sketch. So I'm just going to run through it real quick. So rectangle, then I created a little square over here, so equal sides, and then just placed it in the middle and gave the arbitrary size. Then I created this triangle. I also created 2 lines running through the center of the triangle to find the center point. I added a point there, and I added another point here, an equal distance from the edge. So how I did that was I added a reference line here up to that middle point. I added this another one here and made it equal length to that bottom one, and then I added a point. I made it collinear and I added a point here. So you'll see why I did that a bit later. And then I created a few 2 hexagons and then a circle over here on the side. So I'll just freeze from there for a moment. If you want to see the dimensions, I'll zoom in over here if you want to see the dimensions, if you want to follow along yourself. Okay, so that's the sketch. Okay, then I followed that up by creating a Daton plane. So unsuppressed. So first I created the Daton plane on this point. How I did that was I used the curves and points. So you can also just use inferred. So then you select your face that you want to use and you specify a point. So I can just do that again for you. So I click on this plane and then I click on this point and it realizes, okay, this is what I want to do, and it creates a plane over there. Okay, so then using that I created this shape. So this is what I use to show you guys how to do the sweep or swept feature in NX. Okay, so this sketch, just show you the dimensions. So here it's a straight line 50 high, then arc of 40, another arc of 15, another arc of 10, and then a straight line. These points are horizontally aligned, or they're all nice in line with one another, and then they're connected to these points that I created earlier. Okay, and they were created on this Daton plane. If you guys are struggling to create a sketch on a plane, you can just click sketch and then just click Daton plane, and then it will work. You don't have to select on the drawing itself where the Daton plane is. You can just click on the Daton plane you want to use if that's the case. Okay, so then I first created my base to work on. So this is also very much an informative part. It's not exactly something practical. It's just to showcase a bunch of the features. Okay, so then I extruded this bottom. So simply I used region and boundary curves and I selected everything so that it's one big rectangle and I extruded down. Okay, and then last of all, I believe it's these that I extruded. Let's quickly see, unsuppressed. Yes, I extruded all 3 of them. Okay, so first, if you guys want to follow, this is arbitrary, but I extruded it 10 down. And these 3 shapes with region and boundary curves, I extruded them 50 up. Okay, so now I have my base from which I'm going to showcase the new features. Okay, so all this should be familiar to you. You should be able to do all of this. Okay, so first is the swept option. So essentially the purpose of this is, so you'll find this over here at surfaces. So normally everything's at home. You can find this at surfaces. You will also learn a bit about curves, especially the helix in one of the other videos, but that's neither here nor there. Okay, so swept is for a bit more complex shapes, which you won't be able to create with normal extrusion. So essentially, I want to create a shape which is which has this form of a triangle, but it follows along this path. Okay, so let me unsuppress this and you should be able to see a bit easier what I mean. So literally it went and it took this triangle and then it swept it along this curve, and that creates then this interesting form. Okay, so that's essentially what swept is. An important thing about swept is all the curves that you use as the guideline. So let me just open that. So if I double click on that, so you select the curve that you want to sweep, that's this triangle, and then you select the guidelines. Okay, now the guidelines must be tangent to one another. You can't have any edges there, otherwise, or angles or points. It has to be all nice and continuous, otherwise it will break and it won't go any further. Okay, so they must be it must be a continuous smooth line. Okay, and then there's a bunch of other things you can do. The orientation, so I want to orient it. You can play around with these features. This is just the basics. Okay, so that's how you sweep. Very, very simple. One caution that I'll give you is if you create a part which you need to then draw, if you made it with sweep or swept, it's quite difficult to draw, because you see this, it doesn't handle it the same as a normal face. So it doesn't say, okay, here is a straight line and then there's an arc and then there's another arc and so on. It's all one continuous face. So that makes drawing a bit more difficult. So if you want to do drawings of parts, you may need to use another tool, but this is nice for something that's very complex and something that will typically be made with additive manufacturing, such as 3D printing. We don't really need to give technical drawings of the part, except some critical dimensions perhaps, but you can play a bit more around with fancy options. Okay, so then I simply united these two. So now if we go to selection filter, solid body, they're all one piece. Okay, so now next I added two more Daton planes. So first I added a Daton plane over here. So that is, I created it at a distance from the horizontal, 30 up, and I believe this one I created 60 up, if I'm not mistaken. Yes, 60 up from the horizontal. Okay, so then using them, I'll unsuppress both of these. I created two more sketches. So first is this one. It's again a square, but this time it is rotated through 45 degrees, and its middle points are, let me just hide this again. So its middle points are on the corners of the bottom square. Okay, so you don't need actual dimensions for that. It's all constrained according to that one. And for this one, yeah, I actually gave dimensions, I believe. No, actually I didn't. So for this one, its corners is at the middle point of the bottom square's edges. Okay, so don't need any dimensions. You can just add them like this. Something that you may run into, a problem that you may run into, is if you create a rectangle and it doesn't want to allow you to rotate it. Just check if you don't have any horizontal or vertical constraints on the rectangle or square, same difference. Then it won't allow you to rotate it. Just is that little, let me quickly show you. It should be in this sketch. You see this little rectangle that's over there. That shows that it's horizontally aligned. Yeah, you can also see. So you should know this by now, but if you didn't know it, now you know. Okay. So next, we're going to show you through curves. So that's the next option next to swept. We're not going to through a curve mesh and so on. You can really go on your own time and play with all these different functions. If you struggle, there are other videos also on YouTube that will help you. We don't have time to cover everything. So through curves is essentially, I want to extrude this in air quotes now, but I want to go from this shape to this shape and then to this shape. Okay, so let me unsuppress that. So now I can sort of see what I mean. It took these points and then it extruded it while twisting it to fit this shape. And then it didn't really twist, it just, well actually it kept the arc going. So it kept it nice and tangential to one another. So then it connected up to this one following this little curve. So this is very much NX thinking about what you're trying to do, trying to figure out what you're trying to do. So these points correspond to one another. So let me quickly go to the selection list. So first I selected the bottom one, then I selected the middle part, and then the top one, and it sort of figured out where it wanted to go. Okay. You can play around with a bunch of these options. You can do a bunch more. This is just very simple, basic options, what it can do. Okay, so this is with stock standard, just selecting curves. Okay, so that's the through curves option. So now we move over to synchronous modeling. So the purpose of synchronous modeling is predominantly you'll do it for two reasons. One, if you do not want to break your model that you created. So if you created something and need to change it, but there's another feature that's dependent on this feature, so you don't want to break that dependency, so then you can use synchronous modeling, because let's say this unite is dependent on these previous parts being where it is. So let's use a better example perhaps. So the sketch is dependent on this Daton plane. So you see it highlights the parents. So this sketch is dependent on this Daton plane and on this other sketch and on the Daton coordinate system. Okay, so now if I change any of those, it might cause problems with the sketch. So for the Daton plane, it's obviously where it's drawn. For the sketch, it's these points that it corresponded to. And then for the Daton coordinate system, that is what the Daton plane is defined upon. So if you change any of these, it will break that. It could break that. So now if you want to change things, you can use synchronous modeling, because it will be after it on the feature tree. So it cannot change or break any dependencies that's before it. Okay, so that's the one reason. The other reason is if you get, in air quotes, a dumb part. So if there's nothing here, it's just, it says it's a body. There's a coordinate system and there's a body. You don't have any, you don't have a feature tree for it. So this will be common if you get, for instance, a plastoid file or so on, specifically from someone who used another CAD package. So then you don't really have that feature history to go back and change on. So then you can use synchronous modeling. For your homework, you will get something like that. I'll give you a plastoid file and you will have to import it. I'll create a video for you guys to show you how to do that. But yeah, then you'll have to then make changes to that part for which you don't have a feature history. Okay, so those are the two main reasons you might want to use synchronous modeling. So we're not going to cover everything. There are a lot of features that you have here. So go around, play with them, but I'm going to go through some of the basic ones. So first, I took this hexagonal prism and I added a bunch of edge blends to it. You'll see why later. So then the first one I used is move face. Okay, so for move face, there's a few options. So I'm just first going to, so 2025, okay, I'm just gonna unselect everything. Okay, and just reset this. There we go. So there's a few options you can, it's like reset. And there we go. It's not resetting. Oh, it's because it wants to reset in what it was already. Okay, never mind. So you have a few options. So you can do a distance and an angle. So you move the face a distance and also move it at an angle. You can do them individually. You can do distance by points. So, okay, I want to go the distance that's between these 2 points. I want to move this with the same distance. Then, which is close but not the same, from point to point. So then you can create it. Okay, it's at this point currently. I want to move it to another point. So you can rotate by points, play around with this, but we're just going to do the basic distance and angle. Okay, so I want to change this face, and now I want to go a distance. So here you can see your distance vector shows, okay, it goes up and now it goes down. I want it to go down. So that's this little arrow. So then the pivot point, that's obviously the point where it will pivot around. So you can just select a pivot point for it. I'm just going to leave it wherever it was. And then you can select on which plane it should pivot. So it should pivot on this plane, on this plane, on this, oh no, I misclicked, on this plane. Obviously that won't work. So yeah, that's the options there. And now I accidentally changed the thing there. There we are. So you have quite a few options there. Then you can say, okay, how much must it move it down, and then at what angle? So let's say you should go 30. And okay, I'm just going to cancel and go back in because I broke it while I was busy showing you. So you can change that to 30, so it goes down further. You can change that to 10, goes down less. Go back to 20, and the angle, obviously, you can change that to your heart's content. You can do 1 degree if you want to create something that's just a bit askew. I think it was 25. Okay, so that's the move face option. Then you can delete faces. So I'm just going to unsuppress this. So essentially all that I did was I said, okay, I want to delete this face. So then it took these faces, so this one, and extended it until they met one another, and also this one, and obviously the bottom, to delete that face over there. Okay. I deleted a few more faces, so you'll see something change over there. So I just essentially selected those 3 edge blends and just deleted them. So it just extended these edges to be until they had corners again, or edges again. So very, very simple, just extends the faces. So if I were to, let's say, delete face again, say this one, it will break because these ones are parallel. So it will just go off into infinity and never actually close the face. Okay, so that's just something to keep in mind. Okay, now replace face. So that's a fun one. Essentially, you click on a face and say, okay, let me just unselect here. I want to replace this face. And you select what you want to replace it with. So if you say I want to replace it with this face, it will extend this face until it intersects it, and it will replace it. I selected this top one, so now I get this interesting curve on it. So if I say okay, go to my right view, you see it's perfectly in line with that. So you can also use this to create a bit more complex shapes. Obviously, it goes without saying, all these very complex shapes, to put it on a drawing will be nigh impossible. So this is more when you have the flexibility of 3D printing or the like. Yeah. Okay, so that was replace face. Very simple, it replaces a face. So now we can have resize blend. So we're essentially just going through all these options at the moment. So if I unsuppress that, so essentially you can select a blend and then resize it. It's currently on 2, change it to 5, change it to 5, change it to 10, now it's 10. So you can just change that. So obviously, if you want to go back and just change the edge blend, it should be fine. But if you do not have your feature tree, then this will be useful. So also, if you don't want edge blends anymore, but you don't have a feature tree, you can just remove them. Okay. And then the last one we're going to be doing is radial dimension. So essentially all that is I select this cylinder and say, okay, I want to change its radial dimension or diameter or radius. Doesn't matter, pick your choice. And then, okay, I want to change it to 30. I believe it was on 20. So you can just change it to 30, say, okay, now it's bigger. As easy as that. And yeah, so now you still have a bunch of other options. There are linear dimensions. You can change angular dimensions. You can pattern faces. You can mirror. You can change a bunch of different options to relational options to relate one thing to another. One thing that you can also do is if you have a 3D model, which is very problematic, there's a bunch of curves which it doesn't really interpret as curves, or it has difficulty figuring out what it is. It breaks easily. Perhaps even the model is not solid. There's a problem where, let's say, for instance, if this thing were exported and it broke, then somewhere over here there's an opening and now it's no longer solid. So then this optimized face will try to find all the different features and try to fix the part for you. Okay, so sometimes if you get a really bad part in a plasmid file, so now you can first do optimize face and then try out the synchronous modeling. So because you already don't have features, so this will remove your feature tree. So that's something to keep in mind. But if you already don't have one, then chuck it. Okay, if you have a feature tree, well then go back and fix your problematic model. Don't just use optimize face. Okay, you will notice, or you would have noticed in the assignment that we gave you a few weeks earlier, that just said body. So I wanted to remove the model history so that you guys don't mess it up. So I just said, okay, optimize face, it removed the model history. So then you had just a part which you could draw, so you couldn't accidentally break anything. Okay, so yeah, so that is it for the example video. Obviously you need a code word again. So for this week for me, it will be vernier. So yes, this is quite more advanced than what you already did, but it's starting to get out of the realm of what you really need to know for the Xcel course. You'll be doing this in a bit more depth in next year if you guys have CAD. So if you're going to be doing anything except chemical engineering or the other engineering fields, will have CAD at least in the first semester. So then you'll learn a bit more about this, but this is a bit more of the advanced features if you want to go and play around with them. So yeah, that's it from me. I'll stop this video now. Good luck with the week and enjoy the rest of the videos. Cheers.